So the next kind of compound we're going to talk about naming is a binary type 2 compound, right? And again, binary means it's only formed of two different elements, and compound means there are different elements. For a type 2 compound, we have a metal and a non-metal, but the metal forms a variable charge. So when we talked about type 1, we said it was a metal from group 1A, group 2A, aluminum, zinc, cadmium, or silver. So if it's one of these other metals that can form a variable charge in here, then it would be a type 2 compound. And one of the trickier parts about type 2 compounds is trying to figure out what charge they are and then balancing them. So let's look at how we would could handle these kind of compounds. So if we have a FeCl3, and we find iron on our periodic table. Iron's over here in the metal group. It's up here, right? And so iron forms a variable charge, and so it qualifies as a type 2 compound. It's connected to a non-metal chlorine, which is a halogen, so it has a -1 charge, right? So what we have to do, since iron can form a variable charge, is when we name it, we have to say what kind of charge is on it, and we do that with Roman numerals, right? So we're going to have to figure out what charge is on this iron to balance the negative charge from the chlorine. So chlorine always forms a -1 charge because it's a halogen over here, right? And so if we have 3 chlorine ions, then we have a -3 charge. And so to balance that -3 charge, our iron has to have a +3. So then we know that the iron's charge is 3, so we put iron 3 in Roman numerals to distinguish the charge on the iron cation. And then we name the nonmetal the same way we did with type 1s. The chlorine changes the end of his name to chloride. So we'd have iron 3 chloride. Right, and why that's important, right? Because if we look at something closely related, if we have FeCl2, then we have a type 2 binary compound between iron and chlorine, but we have a different ratio of iron to chlorine, right? And so in this case, we have 2 chlorines, each with a -1 charge. So to balance that overall -2 charge, our iron has to have a +2 charge, right? So then we would name this one iron 2 chloride. Right? And if we didn't put the Roman numeral 2 or 3 in there and just called it iron chloride the way we do with the type 1 compounds, then if someone told you to go get iron chloride, you wouldn't know if they meant this compound or this compound. So we need the Roman numerals in there to distinguish between the two different compounds that can be made between iron and chlorine. So these can give people a little more trouble because you're adding this extra step of finding out the charge, when in type 1 binary compounds the charge is always constant, right? And so that was an example of taking the formula and finding the name. But what if we have something like mercury 2 oxide, right? And so to go reverse, what we have to do is figure out how to balance these things. We know this compound is made out of mercury and oxygen, but we need the ratio of those to write out the formula. So this is telling us we have mercury with a +2 charge, and we know oxygen is here in group 6A, so it always has a -2 charge, right? So if we have a +2 charge, it can go together with a -2 charge, and those will cancel. And this is where this cross multiplying may get you into trouble. If you put a 2 there and bring this 2 here, you would think the formula would be Hg2O2, but that'd be incorrect because they have to be the smallest whole number ratio that goes together. So it'd be one mercury cation with one oxygen anion, right? And so that's how we go from the name to the formula and the formula to the name. So let's look at a couple more here. If we had a mercury again, but we had Hg2O, then what we have to do is figure out the charge on mercury and write out its name. So we start with the metal. The metal is mercury if we find it on our periodic table. It's here in the transition metals. We're going to need to figure out the charge to put in Roman numerals. And then the oxygen becomes oxide, right? That's some fabulous penmanship there, but other than that, it's correct. Right, so oxygen is here in group 6A, so we know oxygen is going to have a -2 charge. We have 2 mercuries here, so this 2 has to be balanced with whatever the mercury has. So if mercury has a +1 and a +1, then we have a +2 from here and a -2, and so our charges are balanced. So we know that each of these mercuries must have a +1 charge on it, and so we'd have mercury 1 oxide, which means 2 mercury for every oxygen. Previously, when we had mercury 2 oxide, there were 1 mercury for every oxygen atom. Let's practice a couple more. All right, so if we let's go from name to formula. I think we've been going the opposite direction a lot here. So so if we have tin4 fluoride, right? So in this case, we know that the tin has a +4 charge, and fluorine is one of our halogens, so it has a -1. So we have fluorine with a -1. We have tin with a +4, right? So when we come down here, we have a +4 charge. We need to balance that with a -4 charge, right? If each fluorine gives us 1 negative, then we need 1, 2, 3, 4 negative fluorines, right? So now we have a -4 total with a +4. So that tells us that we have 1 tin for every 4 fluorine. So we would have SnF4, right? So that would be our tin4 fluoride. Let's try one more, go in the opposite direction. So if we have CrCl3, we would look at this compound and determine, do we have a metal with a non-metal? In this case, we have chromium from our transition metals. So the metal forms a variable charge because it's not in a group 1A, group 2A, or one of these 4 elements. Right. So to find the charge on the chromium, we have to know what the charge is on our negative side, on our anion. Right, so chlorine is one of our halogens, so each chlorine has a -1 charge. So we have 3 -1 charges, we have a -3. So the chromium has to balance that -3 with a +3, so this has to be chromium 3+. So we have chromium 1, 2, 3, and then chloride. Right. And that's how we do binary type 2 compounds in both directions, from a formula to a name and from a name to a formula.